This is the last question from the November 2017 government, national government grade 11 exam, or exemplar, I guess. And here it is. It says, determine the equation of the axis of symmetry, which has a negative gradient. Leave your answer in the form y equals mx plus c. Well, if you know how hyperbolas work, you know the answer is y equals minus x plus c. It's just -1 or +1. And then all you do is take the asymptotes, y equals 1 and x equals -2. And instead of y, put in a 1. Instead of x, put in -2. And then just figure out what c is. So that's minus minus 2 is 2. We subtract 2 from both sides. We get c equals -1. 1 minus 2 is going to give me the -1. Just solve this simple equation. Now we know that c is -1. So the equation of the axis of symmetry with the negative gradient is y equals minus x minus 1. Okay, now we're going to look at this um, last question where it says sketch the graphs of f and g. Well, we know that -3 and 4 is a point for both f and g. We did that in the first two questions. We know that the x-intercept of f is 1 and the y-intercept is -0.5. We know the shape of this hyperbola is a branch in the second quadrant here and in the bottom one right here. And the asymptotes are the key. For, for, the, for the first function f, you just go y is always equal to 1 and x is always equal to -2. And that's the key to getting started. X is equal to -2, then you're kind of set because that makes the frame of the hyperbola. You know it's going to go through -3 and 4. You know the x-intercept is 1 and the y-intercept is -0.5. So there's your two branches. For the exponential equation, you'll have to put 0 in there. 2 to the 0 is 1. -4 is -3. So it's going to go through -3 right down here. I didn't make that, but there it is, right there, right at -3. And if you let it equal 0, if you let y equal 0, then x is going to have to be -2 to make this work. You just solve that equation. Let y equal 0 and solve it, and you'll see that x is -2. And there it is, because 2 to the -1 is a half, that makes it a the shape of this exponential graph is it's taking off to the left. And its asymptote is y equals -4. And I've used this little green line here. That's the bottom, kind of the airport, the asymptote that it never touches, but it takes off from there. So it cuts through -3 and -2, and we know it goes through -3 and 4. Okay, well, there's the two graphs all sketched with their asymptotes and intercepts and the point that we figured out in the first two questions. Now, the last question. They tell you that if f of -1 and g of -1, if you put -1 into either of these functions, you'll get -2 out for y. And -1 and -2 is the point of intersection right there. Well, that's really important for answering the next question, which says, which values of x will there be? Determine the values of x for which g, the exponential function, will be above, g will be above the hyperbola, which is the black one. Well, right here, down here, the hyperbola is above the exponential, but something special happens at -1. Right at -1, it's both are equal to, both are equal. As soon as I go here, ooh, looks like f is above g, which is the red exponential. It's above the hyperbola all the way to -2. But at -2, hey, things fall apart because there is no hyperbola there. So it's just everything less than or equal to -1 or greater than -2 or greater than -2. Better make that -2, greater than -2. Okay, that's you can see that g, the exponential thing, is above here. Well, whoop, now it's below, right on the other side. The exponential ones are below. But right at -3, they equal each other again. And now g is greater than f. On this side, all the way, this exponential thing has gone way higher. And you can see right here that it's above, it's greater than the hyperbola. Anything less than or equal to -3. So there's your solution. In between -1 and -2, but not including -2, and anything to the left of -3, any x is less than or equal to -3. That part's a little tricky. I like to use a vertical line that helps me answer the question kind of in my mind. I have this kind of a line to make it work. Okay, well, that's it. That's the last part. Okay.